All right. Thanks everyone for joining. This is our Zoom meetup for September 2022. We are blessed to be hosting Kautuk from the Ethereum Foundation, from the Privacy and Scaling Explorations Group. Kautuk is a team member of the BLS-Wallet, which is a wallet that is for L2. And we'll let Kautuk share a lot more about that for all of us. So Kautuk, the floor is yours.
Yeah, thank you so much for having me. Thanks, Chi, and thanks, Harit. You guys have been amazing. And yeah, should I start the presentation?
Yeah, go ahead.
Okay, all right. So yeah, hey everyone. So I'm from the PSE team and we are working on a project called BLS Wallet. So BLS Wallet is a L2 smart contract wallet, and it also has a bunch of cool features like transaction aggregation, account abstraction, and some other things which we'll be going to talk about shortly. So yeah, before we begin, I would like to introduce my team with you. So we have Jake, we have James who's leading the project, then we have Andrew, and quite recently, it was just four of us, but quite recently, John and Blake joined us, and they are also helping us build the extension and trying to build adapters for external wallet providers as well. So yeah, this is our team. And yeah, so let's talk about why do we need BLS wallet in the first place? There are so many wallet options, why we are building yet another one. So one of the core problems that there is, that is cost per transaction. So if you see on this axis, we have the feasibility, and on this axis, we have the transaction cost. And the feasibility of any application decreases quite rapidly as the cost increases. Obviously, if doing transaction costs more, then there will be a lot of friction and the users won't want to do that. On top of that, it also has an impact on top of it. So again, if you have cheaper transactions, if you have more meaningful interactions with the applications, more users will be joining it, and the impact that they'll create is much higher as compared to increased transaction cost. So some of the use cases for that is you know if you see on the graph, we have casual games which has a moderate amount of transaction cost, but as we go up for a more sophisticated application, so high value to asset transfer, or DeFi front running, or if there is a cool new NFT drop coming up, the gas price just shoots up anything. And also if we want to develop microfinance applications, like microtransactions or smaller scale transactions, so we would require the transaction cost to be actually less than what you are actually doing. So it doesn't make sense if you are doing a microtransaction and the gas is even higher than that. So that's something we have been focusing on. And to solve that, there have been quite some attempts. So we have rollups, we have Arbitrum, Optimism, which is EVM compatible optimistic rollups. Then we also have a bunch of ZK rollups coming up, like ZK EVM. Those talk about EVM compatibility and stuff. So where our solution lies on is within the same layer of L2s, which is building on top of EVM compatible rollups, so that we have the additional advantage of BLS compression. So, okay. So what exactly is BLS wallet, and why do we want that? So everyone is aware of L2fees.info. It shows uh, how much average cost is for particular transaction. So if we compare over here, so a single token transfer on Arbitrum one costs 45 cents normally, but if you use a BLS bundle, which the wallet provides, you can do it in 10 cents. It's even better for Optimism. So it's around 20-25% decrease in transaction cost. So this is that, and this is a data from 3 or 4 months ago. We know that the gas prices have gone down significantly in the couple of weeks. So, but still, we still can do better than that. So L2 smart contracts, what they are. So for L2 smart contracts, we have BLS signature scheme. We can even support gasless transactions. We can have account recovery built in. We can have upgradability. So if your wallet, some features are added, you can just migrate your existing keys. And one of the coolest thing is multi-action, which we'll be talking about shortly. And all of these points that are mentioned are a part of the the proposal, which is EIP 4337, which is the account abstraction proposal. And we are also working closely, like James is actually contributing to the reference implementation of 4337. So that is a really nice thing for us as well. All right, so standing on the shoulders of giants, so we are not starting out from scratch. We are actually building on top of existing things that the PSE team has already built, and we are just like using some of the existing tech to like build some interesting stuff. So BLS, the elephant in the room, the BLS signature scheme, which stands for Bone, Lin, and Shacham. I'm sorry for the pronunciation. So it is a cryptography pairing-based signature scheme. So what happens is like you have a curve, and on that curve you have several points, and you can have message, and it actually pairs to you can have multiple messages like paired with each other. So yeah, so where it is being used, so like the consensus layer is using the BLS 12381 curve, and like the execution layer is working on like BN 254 curve, and this is also the curve which we are actually using. It is not the one which the consensus layer uses, but it is like beneficial to us because there is already a precompile for this with the EIP 197 release at 0x8 address. So this is what we are using right now. So what happens is when L2s are writing new states to L1, what they do is for every transaction, there is like an ECDSA signature for each transaction. And if you take into account the number of transactions coming in, if each transaction has, like if there are X transactions, then there are like 2X amount of data going on L1 because of all the ECDSA signatures attached with each transaction. And also if you see for multi-call, so for multi-call, you can do like one transaction and it will actually do like multiple of them, but it does not easily allow for like batching of transactions. So it will still be like independent transactions from there. So how it actually works, like in a very generic sense. So let's suppose each of the shape over here is a transaction, and the box enclosing the shape is the signature. So if you are doing it in a traditional way, what you'll do is like you'll post this on chain on L1, you'll post this on L1, you'll post this on L1, and it will be like 3 different things. But what BLS allows you to do is that you can have all these transactions together, like kind of like superimposed on top of each other, and you can have like one single signature that is like incorporating all of these transactions. And this is how like the signature aggregate, you have like message 1, message n, like you can have n number of messages, and you can sign it with different private keys. And what would happen is that you can actually use one signature to actually verify if all the messages were signed correctly. So you can read more about it, like going in depth would be like read very time consuming. So you can read more about it at this particular link. Right. So it started out, like I said, we have been building on like a lot of existing work which the PSE team has been doing. So I was also like part of this project, which is the Hubble Optimistic Rollup project. So what this was, it was an ERC20 focused optimistic rollup. It wasn't EVM compatible, but it provided a very cheap way of actually transferring ERC token from one address to another address. And it used BLS signature underneath it. And it also had like signature aggregation built into it, which actually helped it to become one of the cheapest solution for ERC20 transfers. And like right now, the WorldCoin project is using BLS Hubble optimistic rollup as their underlying transfer layer. And the libraries created during this time was actually like the core libraries which are used for the BLS wallet itself. So yeah, coming to our project. So like I talked about, the core components are smart contract wallets, aggregation service. We have also a client module, which any other application can use to build their own system. And we also have a reference browser extension, which is called Quill. So what Quill allows you to do is you can actually replace the existing browser extension, let's say MetaMask, if you're using that, and just install Quill, and it will actually help you do BLS-based transactions. So yeah. SL2 data per transaction, less L1 gas. So yeah, we already talked about that. And yeah, these are some of the numbers which we let me move this around. Yeah, these are some of the numbers which we ran during the estimation part. So if you see over here, like BLS, one second. Yeah, I'm sorry about that. The Zoom thing is like coming in between. Anyway, so in the top row, it's the BLS transactions, and in the bottom row, it's the normal transactions. And we have done the gas cost estimation on Arbitrum. And these are like based on 31 token transfer from one address to the same address on Arbitrum, and deduplication of sender, token address transfer. Anyway, so if we see like the total amount of call data used for BLS signatures is like significantly lower than a normal transaction. However, like the transaction units on L2 is more because we are doing a lot of pairing and those kind of things. So this is actually greater than normal transactions. But however, since L2 computation is so cheap that in the long run, and by actually aggregating so many different signatures, this actually comes out to be at a lower cost than normal transactions. So if you see over here, for the total cost, you can see that total cost of all the 31 token transfers was this much, whereas for normal transfers, it was this much, which is like a 25% improvement over the total gas cost consumption. And yep. You can read more about it by scanning this QR code. It will take you to this link, and it has like a detailed analysis of gas cost estimation. So how the project is set up today for the configuration right now. So we have the browser extension. So the browser extension actually embeds the client module, which I talked about. And this client module is actually responsible for making the connections. From the client module, we have the aggregator service running. So whatever transactions that you want to do in the browser goes to the aggregator, and then the aggregator actually like combines all of these transactions into a bundle, and then the bundle is submitted on an L2 node, and which goes through the BLS verification gateway. This contract is actually responsible for verifying BLS signatures if all the transactions coming in together are signed properly or not. And once that is verified, like the individual smart contract wallets are then used to execute those transactions. So this is the entire flow right now. And like for scaling integration, it's like you have a dApp, and the dApp has like a bunch of operations. So this is the multi-action thing, which we are going to talk about shortly. What you do is like you have an operations array, and you send that to the BLS client module. It will actually sign all of these and then send to the aggregator. So the interesting thing is that these operations need not be coming from a single wallet. What you can actually do is like a bunch of different wallets with different public keys and private keys are actually gonna send these operations. However, like the aggregator will actually combine these together. So it need not come from the same source. You can actually leverage like the more the merrier. So if there are more transactions coming in, the amount of data saved would be even greater. And then the aggregator like submits a bundle of transactions. Yep, this is the operation flow for the contract side of things. So the bundle is submitted on chain, and on the EVM, what happens is it goes through the expansion first. So all the compressed signatures is expanded to extract the individual transaction. Then the signature verification takes place, and then based on whatever action is going on, whatever operation has been submitted, it will be transferred to the contract wallet. And once the contract wallet gets the transaction, it will send the action to the dApp interaction or whatever interaction that is going on. Great. So let's see a small demo of whatever. I just lots of words and like nothing interesting right until now. So let's check out some cool stuff. So this is the wallet which I talked about. This is like the reference wallet. We are just building like a reference implementation so that all of the functionality that is there, we can like demo it to whoever want to demo it. And it includes like aggregation and like BLS signature verification built into it. So just to demonstrate, like let's take this address, and you don't have to do anything differently. So we have MetaMask right over here. And if we just do like try to do like a simple transaction just to this address, let's say I want to send 0.1 ETH to the outside world, even though this is a smart contract wallet. Let's wait for a few seconds. So even though if this is a smart contract wallet, there is no noticeable difference between these two. So it will just act like as any normal wallet. So we have some ETH here, and if we want to send ETH from here to back to the original wallet, just copy this. So the interaction will also look exactly the same. Like we have like a similar pop-up to MetaMask, and it will show you a bunch of things. But like the interesting thing will come next. So once I confirm this and I go to, so this is the aggregator running in. So this aggregator is actually like collecting all the transactions coming in. So if I refresh this real quick, these are some of the old transactions. So yeah, you could see a bundle being created over here. So the aggregator sees the bundle. It will actually wait for more bundles to come in. But right now, since there is only one bundle, it will just try to aggregate that. So it makes a submission attempt over here. And once the submission is like confirmed, you will see a submission confirmed message. And right now there was this only one transaction in the bundle. So it will just give bundle hash for one, but actually like if there are multiple transactions going in, it will show the hashes for each one of them. And if we see over here, oh, where did it go? We can see that the transaction was confirmed, and this is a very similar thing, similar transaction layout as any L1 transaction, with one difference, which is not sure if it's here. Yeah, it's in the aggregator itself, so you can see over here. So you can see that the hash is the aggregator hash, whereas the L1 hash is a little different than this. All right. Moving forward, the other thing is how it actually interacts with normal dApps. So this is just a demo application which I built to demonstrate ERC20 transfers from BLS Wallet. So this is like a token contract over here, and this is like a spender contract over here. So what we can do is we can just call a mint function, and you can see like a similar interaction over here. So it will just send this, and just waiting for a couple of seconds. Everything is running on Go Early right now. We have the contracts deployed, the verification gateway deployed on this thing, this network. So once some tokens are minted, what we do is we can approve this spender contract to actually like pull, to actually give permission to pull the tokens. And let's wait for it. Oh, I'm sorry, there has been a power cut. No worries. So once this goes through, we will be able to pull tokens into the spender contract. So I think it was successful. And now if I do a pull, so you'll be able to see that the tokens will be pulled from the user into the spender contract. Waiting is not interesting. Yeah, this is much faster.
How many contracts are there in total?
So there are just two contracts. One is the token contract and one is the spender contract. So it's just that like pulling tokens requires an approval step. So I just wanted to demonstrate that right now there are 3 steps involved, which is mint, then approve, and then pull tokens. And if we check out the aggregator, so we can see that 3 transactions would have been submitted over here. So this is the usual way of doing things. So submission confirmed, submission confirmed, submission confirmed. So 3 transactions took place right now, but with what we can do with BLS Wallet is that we can bundle all these transactions together. So over here, this is the coolest thing. So there are like 3 transactions. So we'll just verify each of them. So we see that there are 3 transactions coming in, which is mint, approve, and pull tokens. And if we just confirm all of these together, this is just one transaction that's going to get submitted over here. So you can see that bundle added, and this bundle was just one transaction, but submission confirmed. So over here, you can see that all of these 3 atomic transactions took place in like just one transaction, and only one transaction was submitted on chain. So this was a demo for like simple multi-action thing which the extension can do. All right. So coming back to the topic, how we can actually use the client. So this library which we have posted on NPM is just like NPM install BLS wallet clients, and you'll get like a wrapper for aggregator, you'll get a wrapper for BLS wallet. So what you can do is you can create a wallet this way, and you just give it a private key, just the verification gateway address and the provider. So it could be like in the browser, it could be the wallet. In any other application, it could just be like a JSON RPC provider. And then for the aggregator, how we actually submit the transaction is just that we call wallet.signer.aggregate, and then we give it a bundle or another bundle or however many bundles that we want to give it to. And then we call aggregator.add, and it will send the request to aggregator. The aggregator will combine it and then submit it on chain. So it's very user-friendly, developer-friendly. So yeah, connect to the wallet, create and sign a bundle of operations, aggregate multiple bundles together and send it to the aggregator. And this is how you actually create a transaction. So inside this, we call wallet.sign, and this is the signing process taking place. And for multi-actions, so instead of like doing the actual transaction, you just call the encode function data on the transaction. So right now it's approve, and give it whatever details it needs, and just the call data is required. So you just say add a call data in one of the array and another call data in another of the array, and you just call approve and swap in a single transaction. All right, why should you use BLS wallet? So we have use cases for dApps, we have use cases for external wallets, and we have use cases for L2 nodes. So dApps and wallet, what you can do is like you can have multi-action support. So like I just demonstrated over here, and you can also have like cheaper or even gasless transactions. So right now, if you saw in the demo, where did it go? I had like 0.1 Ether in my wallet, and I still have 0.1 Ether in my wallet because the aggregator has been like sponsored to actually aggregate my signatures. So you can also run it in like a sponsored mode, or you can actually like fund the aggregator yourself, and it can actually do like a gasless transaction. And yeah, it has bundling support as well. So if you are familiar with normal meta transactions with relayers, that doesn't like bundle transactions together. So that would still like have multiple steps involved. But over here we have bundling. So instead of submitting multiple meta transactions, you can just submit one. For smart wallets or for like a third-party wallets, what we can actually do is, let's say we have Gnosis, we have Argent, they can actually like use the client module within their own wallet, and then they can take advantage of account recovery and upgradability. So right now, if you lose your private keys, it's done. You can't recover it back. But for us, you can actually like sign a message with that, keep it stored, and then what if you want to change your wallet to a different address, you can still do that. For L2 nodes, let's say for Arbitrum or for Optimism, what you can do is like you can reduce the gas on EVM transactions. So if you might have observed during the Arbitrum Odyssey events, the gas prices are shot up like anything. And it was so bad that they had to like shut down the entire operation. But if they had used transaction aggregation, so they could have like a combined bunch of transactions together into a single one, and that would have actually like help them run their event much better. And we would also encourage adoption of dApps and wallet by actually making the applications sponsored. So for any users who's like a first-time user of an application, they are required to have some amount of Ether in their wallets, but that creates a lot of friction, right? So what they can actually do is the dApps can sponsor some of the transactions for them. And once they are like, okay, that this is the application that they want to use, they can actually like recover their wallet. They can actually recover their wallet to an extension and then just start using it normally. Right. So future configuration options. So right now we have like a browser embedded model. We can also do mobile wallets. So the mobile wallet will include like the client module, which will just talk to the aggregator and then like talk to the third party contract wallets, which is like anyone running a wallet. Yep. Next steps are like to facilitate like faster adoption into dApps and wallet. So we are like working on like some nice integration docs. We already have like a repo up, which anyone can check out and like start using the application, start using the client. And we are also working on like solidifying 4337 and like talking with external wallet providers. So we have been talking with a couple of them, and they are actually quite excited about like including BLS wallet with their own wallet. So yeah. And you can join the Discord channel for Web3Well. So Web3Well is an organization which we Discord channel which we created, where like you can discuss about development of BLS wallet and actually like provide ideas, contribute, etc. And yeah, this is the project link, so you can go to the GitHub and check out the project. Yep, open for questions.
All right, thanks, Kautuk. So as per usual, we generally welcome any questions from anyone in the audience. You can ask it in the chat and I can ask it on your behalf, or you can unmute and ask Kautuk yourself. But before we get into other questions, we always like to start with getting to know our speaker a little bit more. So Kautuk, just like, can you kind of describe to us your experience falling down this Ethereum rabbit hole, like how you came into Ethereum, and then how you came into the Ethereum Foundation and the privacy and scaling explorations group?
Right, yeah. So my journey has been like quite interesting one, because I did not actually start here. So back in 2018 or so, I got into like Ethereum development through hackathons. But at that time, you must remember the tooling wasn't very great and the application development experience wasn't very nice. So right now you can just do like a console log in the hard hat code itself. But back then you had to like do some stuff, like put in some breakpoints and like run everything to the Geth node. And that kind of discouraged me from actually pursuing it further. So I got into machine learning and data science. So I did my internship at that time. I went ahead. I even had like plans to like do some research in machine learning, but then I thought that the space has been like quite it got quite saturated really quick. So I thought that, okay, this is not the thing. And then back in 2019, I believe, or 2020, like around that time, I got interested back into the Ethereum community, because you know the market and everything that got me interested. Honestly speaking, it wasn't the development side of things, but then I realized, yeah. But then I realized that like it's not just about the market; it's about building applications and how things can actually work within the Ethereum ecosystem. So I got really interested in that, and like my first ever like full-time gig was actually like a combination of machine learning and Ethereum, where I was working with Spectral Finance to build like on-chain credit scoring models. But then I got into scaling, and then I started working with the Hubble rollup team. And from there, like building on top of that, then we switched gears and then like moved to BLS Wallet. So how I got into EF was, so basically I created a small project which was a POC for a pessimistic rollup. So everyone was doing optimistic. So there was this post on ETH Research by Barry, and I thought that it would be good to build a POC. Then I posted it, and like it was well received by everyone. And then I got into working with the team. So yeah, that's how I got.
Sorry, could you just in like maybe 2 minutes describe what is a pessimistic rollup?
Right. So it's just a So for optimistic rollup, what we do is we just post data on chain, and we just optimistically assume that it's going to be correct until someone comes and proves it that it is not. So for pessimistic rollup, we have an approach wherein like you post the data on chain, and while posting the data on chain, you actually run through the entire data. So basically like running the fraud proof during the time of submission itself. So by doing that will actually give you like instant finality at the cost of gas, obviously, because that's what optimistic rollups do, that they don't run the data coming on chain. So that had like several use cases. It was obviously not very gas efficient or not very good for scaling, but it had like other applications, like you can build like a super wallet of some sorts, wherein like people who want to do a Uniswap transaction, they can like a bunch of people can come together, put in their tokens, and then just wait until prices are fine, and then they can just execute it, and then like they can take out their share. So it's good for very specific use cases, but like not very great in general for scaling. It was just a fun project.
I helped you get into EF, so that helped a lot. And you mentioned for the BLS Wallet team that it's standing on the shoulders of giants. Can you describe a little bit more, like the history behind BLS Wallet?
Right. So I mentioned Hubble optimistic rollup, right? So Hubble was the first rollup, I think, which used BLS signatures, and the work done at that time, like building the BLS client library and the BLS pairing libraries and those kind of things were the steps that we took at that time. And then we are using the same libraries, like the exact same libraries for BLS wallet.
All right, and like, what was the kind of the end goal of like starting out a BLS Wallet project? There's Zcopru, there's a bunch of other projects under PSE. For BLS Wallet, what's the kind of the vision of this project?
Right. So like we all know like good things about contract wallets, right? So we just realized like it was James who came with the idea, and he was like, okay, we can improve contract wallets, and by improving contract wallets we can actually let existing infrastructure support this. So for ZK Opru or for like new projects, you need to go to a different network, right? But with BLS wallet you can stay in the same network and just like use a new wallet instead of like migrating. So it's good for everyone in the existing network, and it also can act as an inspiration for like newer projects coming up.
Cool. And James Zaki is an inspiration for me personally, at least, because he was running a bunch of meetups, I think in Sydney. So yeah, this was a long time ago. So yeah, one of the people that inspired us doing ETL in Malaysia. Before we go further, Sri just asked a quick question whether you have any links to that pessimistic rollup, like any blog or maybe a GitHub.
Oh, right. I have a repository. It's not a very well maintained or well written code. So I'm kind of embarrassed sharing that, but I'll still do that. 1 second.
Actually, it's great when our speakers have those kinds of embarrassing repos, because then the people who are here who don't feel as intimidated, that maybe they also have a chance.
Yeah, I just shared that in the chat.
Thanks. Okay, cool. Then before I jump into, I think a lot of the questions are kind of related, but before I get there, so one of the key things with having an L2 wallet is that it's multi-chain, right? It can cover not just mainnet, but also other rollups. But can BLS wallet work for other chains like non-L2s or even non-EVMs? Like what would be the range that it can cover?
Right. I mean, it can work only on EVM chains right now, but it can definitely be on non-L2. So you can run the same setup on Ethereum mainnet, and it would still give you gas benefits. But if you run this on Arbitrum, so Arbitrum is already like doing a lot of compression with BLS itself within their sequencers. So that would actually have like a boosted advantage to run on Arbitrum. So I'm not exactly sure by how much in terms of number, but like you can run it on non-L2s, but running it on L2s would be much more cost effective.
And for ZK rollups, is it any better or worse?
I haven't I don't think we have worked on that yet.
Okay.
You can like James, I'll ask James and like let you know if we are like planning to go over there as well.
Yeah, and like all the ZK EVMs aren't actually live yet, so
Yeah,
it's probably have to wait until it's live before we know for sure. Yeah, so getting into some of the audience questions, Chichuan asked, so how many transactions can one bundle contain?
How many transactions can one? So there is no limit to that. Like the limit is like how many transactions a particular block and L2 can hold. So if I'm not wrong, Arbitrum doesn't have that kind of a system. You can have like there is no small limit to no hard limit to how many transactions can go in a L2 block. So that's the limitation of BLS wallet itself. So it's how many transactions can a block on L2 handle, which be the same as how many transactions can BLS aggregate.
And the flip side to that question from two is there a rule for like a minimum number of transactions inside a bundle?
Yeah, there is no rule. You can just have a single transaction. So I just demonstrated like a single one. So there have been cases wherein like existing applications have to modify their code a little bit to have multi-action support. But if you are doing just a single transaction, then there is no need to do that. Let me, in fact.
And do you actually get cost savings? I guess is another way to ask that question. Like, at what amount of transactions does it like become apparent the cost savings?
So like since it's bundling, like just one transaction would also be cheaper than doing one transaction without this. So the cost obviously multiplies as like the cost reduction multiplies as more number of transactions go into the wallet. But like doing a single transaction also, like if you are doing it on Arbitrum, it like reduces the entire call data size because there are some things involved for compression itself. So if you check out the code, I mean, like you can go over the code to like check that out. Yeah.
Okay, cool. And then so Chichuan asked how fast is it to generate a bundle, and Kevin asked, I guess, a related question like, does the signing duration scale linearly over time?
No, there is no cost to the transaction. So I realized that for ZK, like running it through a circuit takes some amount of time, but for like signatures, it's instant.
All right.
And that includes like multiple, like obviously it has some delay. Like I don't know exact in amount of time. It has some delay, but like for actually verifying one signature, it's the same as for verifying like 1,000 signatures. So verification is like instant.
And talking about bundles, I don't know how much you follow the whole MEV thing going on. So does having these kind of like aggregations bundles with BLS Wallet, does that affect MEV, or how does MEV affect it in any way, given that you can combine different transactions from different people and basically just send that one bundle?
Right. So on that note, like since the transactions are expanded during submission, so obviously like these are atomic as well. Like if what happens is like in a bundle, if there are like 10 transactions and one of the transaction fails, then like the other transaction would still like succeed. It's not the case for an action, but for a bundle it is. So like obviously I could see that it's not possible to sandwich transactions in between, but like for MEV, like the entire bundle could be treated as a single transaction. So I think in terms of that, it's like somewhat MEV resistant, but not really like on that case.
So let's say there's 10 transactions inside a bundle, like who or what is the mechanism that orders these transactions? Is it like first come, first serve?
So it's based on the aggregator. So like if you're sending the aggregator a bundle, so since the bundle has like some amount of transaction, it's the aggregator who actually like bundles all the transaction together. So if you are running an aggregator, you can bundle it differently than someone else running the aggregator. So in that case, yes, obviously at that time, like ordering is important, and then that actually can have some MEV stuff going on.
So how do aggregators work, or like is it like anyone can choose their aggregator, or is there some sort of like voting mechanism, or like who gets to be a aggregator?
Yeah, so this is not a network of aggregators. This is just one aggregator. You can just like the aggregator has a single URL and you choose which aggregator you want to work with. So it's that way.
Okay, and like, but multiple people can create their own aggregator contracts. Is that how it works, or there's one specific aggregator? Okay.
Yes, yeah, like but like the thing is, if you are submitting your transaction to one aggregator, then the other aggregator won't be able to like work with it. So it's like anyone can run an aggregator, but you'll have to point your transactions towards that aggregator to actually get it bundled.
Yeah, okay. So I can imagine, I mean, it's probably not so soon, but I can imagine a future where people kind of compete to become aggregators that people submit transactions to, and then there might be some MEV happening there.
Yes,
Um,
on that note, we are actually like working on this exactly. So we have a vision that in the future there won't be any aggregator, right? So there will be MEV bots who will be competing to like get your bundles submitted on chain. So like that's something which we are working on through the payment. So right now, like we are the aggregator just like for the testnet, it just like doesn't accept any payments, right? So we are actually like working on like a wrapper so that like anyone can sponsor transaction for someone else. So that way, like obviously MEV bots would see this as an opportunity, and they'll just grab the transaction and just submit it themselves, bypassing the aggregator completely.
And again, speaking of bundles, but I guess in terms of actions, there are projects like Furu Combo where the whole point of it is you can like put pieces of transactions or actions together and then like submit one transaction. Is there a key difference on the user experience side of using BLS wallet aggregations versus a DeFi app like Furu Combo? If you're familiar.
Like, are you talking in terms of building the application or something else?
Or from the user's point of view, like let's say I want to make a bunch of transactions atomically, like I want to make a swap on a DEX, and then right after that lend the token that I've swapped, and then after that deposit the other token into some sort of farm or staking contract.
I got it. So yeah, I think it's pretty much like it's very easy. Like, so I'll just show an example over here. So this is how a normal transaction works. Let me find it. Yep. So this is like a simple way of like a normal transaction, how it works, right? You just like call the provider and just like send a transaction. But over here, like for the extension specifically, we have modified some of the RPC methods. So this is like the bundle one. So instead of just calling in the transaction directly, you just like do a populate transaction call. And like for populate transaction, you'll just get the call data of the particular function that you want to do. And if you are familiar with like the send transaction method, so this is a simple send transaction method which just submits the transaction with call data, signed call data and everything on chain. So in a normal context, this is the case wherein like for the params array, you just send in one transaction, right? And this is the usual like conventional, not conventional, this is the I forgot the word. Like this is the way how it happens, right? This is the de facto way. But we have modified the RPC inside the extension such that you can like put in like however amount of transactions that you want to do in this array, and just like call this each send transaction, and it will actually like debundle it together and then just perform the bundling itself. So for your question, like you can like one of them could be like getting some tokens, one of them could be like using it on another, sending it to some other thing. Then it's like just you can just keep building it within this array itself.
Okay. And I guess beyond that, it's more like the client-facing interface, the user-facing interface to make it even more user-friendly for the user to do.
Yeah. So like one of the things which I like calling it, you can have like a shopping cart experience wherein the application provides you stuff. You just look, click, and it just keeps it in a cart. And once you are done with the adding of the transaction, you can just check out, and like that will actually submit all of the transactions together. But there are some limitations to it. Right now, what dApps do is that they expect like if you did a transaction, if you click on a transaction, it will actually return you a bundle hash, a transaction hash, and then only you can do another transaction. But over here, if you are doing like multiple one of them, there is no transaction hash until all of them are submitted. So that is a user experience which we are trying to like improve, and like probably in the coming releases of the Quill extension, we'll hopefully have like better UX on that, so that the apps don't really have to modify their own code.
Nice. So Tu asked a good question about UX as well for the user. So when aggregated for these transactions, does the user need to request or do some sort of extra action to get the transaction information? Let's say on a block explorer, like do they need to do something to decompress the transaction info?
Yes. So that is like, yes. So we are actually planning to build like a explorer for the aggregator, because right now if you have 10 transactions, every transaction will go on chain, and there is no like easy way to actually decode it. Like you can decode it, but like since it's everything is in one transaction, it's not really possible to it is possible, it's not very user friendly to actually decouple that. So we might be building something for that, but as of now it's difficult from UX perspective.
All right, nice. And so is the BLS wallet like in a ready state, or I think you mentioned something like waiting for 4337 to be out? Like what's the current status of the BLS wallet?
It is out. You can just use it. It's not live on mainnet or anything, but if you want to check it out with testnet applications, it's there live on Goerli. It's live on Rinkeby, Arbitrum, basically Arbitrum Goerli and Arbitrum Rinkeby. So you can just like go around and play with it. Everything is mentioned in the repository docs. So, and like in case if someone has any questions or want to reach out further, I would advise like joining the Discord server for Web3 Well. So this is the link.
Or maybe if someone wants to do a hackathon project using this.
Why not? Like, we'll really appreciate it. Like, if you build something nice with it, like, we are obviously looking for people to, because this is a new paradigm. Like, up until now, dApps have been like one transaction, one result, one transaction. So, this is entirely a new paradigm, and we want people to build user experiences with this type of transaction scheme. So, I think like it will be a really nice idea if you hack something and like build something, and please share it with us.
So, when mainnet? Is I guess
Okay.
the natural question.
I think once we finalize 4337 and like have everything in place with that EIP, I think after that we'll be aiming for mainnet.
Do you know when 4337 is slated for? It's not for the next like Shanghai, is it?
I am not sure about that.
Okay. But basically it's a prerequisite before BLS wallet can go fully live.
Yeah, like for us, like I think you can definitely deploy the BLS wallet right now in its existing state to any of the chains for mainnet, but like we want to have like the added benefit of 4337 recovery and those kind of things before actually like making it live.
And so for when OneSub was here last month to talk about Zikopru, so he specifically clarified that Zikopru is a not an implementation. It's meant to be created as a research project, as a reference. So does that same thing apply to BLS wallet? Are you guys gonna create your own kind of implementation, or is more for like a public good for other people to build on top of?
Right. So the BLS client module is something which we built so that like other wallets can actually integrate that in the client itself. So we don't have any plan of like creating like sort of a product with this. Obviously, this is public good. Everything in like EF we do is for public good only. We don't actually aim for running stuff ourselves. So the Quill extension also, we just provided, we just built it to provide a reference implementation to how extension could look like. But since we already have put in so much effort, so it's just like you can just use Quill directly right away. But we would actually like recommend other wallets to integrate BLS client, like let's say Argent or Gnosis or like a Scaffold ETH project. So we are actually working with them and trying to get them integrate the clients module. So we don't have like the way of doing things. You can obviously do things your way, but the contracts and like how the verification gateway and those kind of things are built, that is like one of the that is like how we'll push people to build that way. But obviously this is for public good only.
Nice. It's so cool to talk to people like you and OneSub doing these kinds of things. So we have about 5 minutes left. I guess we probably can go a little bit over time if people are okay with that. So if you have any questions that you have, please feel free to put it inside the chat. I think we can go to some kind of like more wider ranging, higher level questions. So TC asks, as rollup technology becomes increasingly prevalent due to cheaper transaction fee and faster transaction speeds, do you think that all future business solutions will fully shift to L2 and derive the functionality of Ethereum L1 only as a base layer for security and decentralization?
Yeah, I mean, that is a very good topic of discussion. I think it was mentioned in the rollup centric roadmap blog post as well. Like Ethereum will, and like this is my personal opinion now, that Ethereum will mostly work as a settlement layer, and like applications will be built like separately while like deriving security from the main layer. So in fact, there is one more project that I'm building on which does similar things. I think like it's not the right time to share it. I'll share it afterwards, maybe separately. This is about BLS, but like in general, I still feel that is true and that should be the case.
Yeah, as Chichon says, that's another talk that we can slate you for.
Yeah, I'd love to.
And so again, on the kind of like wider level things, so you mentioned having like scaling, making transactions a lot easier for people such as those doing microfinance. In your opinion, like what would be one like use case of having, let's say BLS wallet is like completely out there and adopted, and Ethereum has scaled, like what would be one favorite use case of yours that you can use this technology that you built for?
Okay, so I'm not sure, like you guys might be aware of LivePeer. So what LivePeer does, it does video transcoding, and for each segment of transcoded video, it actually does a small payout to the node which does the transcoding part. So over there, the size of the transcoding is like very small, so the payment related to the work is also very small. So if all of these can be bundled together, so it doesn't make sense to submit a transaction on chain with such a low amount of payout, because the gas will eventually be higher than the payout itself. So that doesn't make sense. So this is a nice use case wherein like you can like have multiple tickets bundled together, and you can just submit once and like take the payout for all of them. So this is one of the good use cases which I can think of.
Nice. And so before we end, just quickly, we know there's a bunch of PSE projects that are happening. Always looking to invite more to ETL. So maybe what's one of your favorite other project that's happening? Maybe not one that you're involved in, that might be cool for you to share with us.
Right. So I think like ZK was one of my favorite projects, but you all guys already have like a talk with them. So if I had to choose another one, there are so many projects.
I'm just looking for guests to invite next.
Yeah, I mean, like you can check out Interrep maybe.
Sorry, Interweb?
Interrep. Yeah, so you can check them out, and those are like, those guys are doing like pretty good work there. So yeah, I can recommend that. Yeah.
All right, thanks. Okay, and yeah, so thanks a lot, Kautuk, for sharing your time. Unfortunately, we can't see each other in DEF CON, but if you're ever around in KL or even in this region, feel free to drop by in KL, and like we have a relatively big community here who would be happy to welcome you and show you around.
Yeah, thank you so much. I'll definitely, like, if I ever visit, you will be the go-to people to actually like show me around as well.
Yeah, and if we ever get to doing that hacker house that Chichon's been talking about, then you can even have a free place to stay.
Oh, awesome. Totally in for it.
All right, thanks a lot, everyone, and we'll see you at the next meetup, which is TBD.
No. Let me share something a bit about the next potential workshop we are having. So the next workshop we're having is going to probably it's mostly going to be on the 8th of October. It's going to be a Saturday. It's going to be a Rust workshop. So it's going to be, we are going to write out trading algorithms in Rust. So for those who are interested in trading algorithms or Rust or both, so feel free to sign up for our workshop. Keep an eye on the Telegram group, because I am going to share out the form now. So yeah, just register. Slots are limited, so be quick. We are still deciding on the venue, but it's going to be around the KLPJ area. So yeah. And thanks so much, Kautuk. It's a pleasure having you here.
Yeah, and thanks so much for you both to actually like organizing it and like having me around. So thank you so much.
Oh, we love having the PSC team. They are like very cool and futuristic projects, and they're like so friendly. So I'm always happy to have PSC team come. Right, Harris.
Yep, heroes of Ethereum.
Yes, I agree.
All right, so thanks a lot, everyone, and yeah, thanks again, Kautuk.
Yeah.
Bye-bye.
Bye.